In this video, we want to look at solving trig equations. And let me start off by saying this is going to kind of go back to a lot of our unit circle stuff. So if I would encourage you to pause the video, get out your unit circle, if you have it there, to be able to look at it as you're watching this and understanding what's going on, because I'm going to be referring to the unit circle a lot. And if you, I know everybody memorized it at one point, but it's been a while since we've looked at it. So we're going to kind of go back to that here. Now, before we get into this unit circle, I want to look at some other problems that we've talked about this year, but just to kind of refresh your memory. And I want to start off by looking at the difference between these two problems. One is just an expression, the symbol 25, and one is an equation with an equal sign. Now, from we've talked about before, if you just have the expression, the square root of 25, and if we do that on the calculator, the square root of 25, you get just 5. So the square root of 25 is just 5. It is a single answer. However, if you have an equation and you would solve it by taking the square root of both sides, when you have an equation, you can have more than one answer, and you have to get plus or minus 5, because both 5 and -5 solve the equation. And there was something when you first learned square roots way back in middle school or elementary school, that this was known as the square root symbol, was known as the principal square root, and it was only the positive and so forth. But the important thing to understand here, if you have an expression, it can only equal a certain number. You couldn't have something like 1 plus 3 and say, well, that equals 4, or it could equal 5. That can't work that way for an expression. Now, if you have an equation, 1 plus x, equals 4, now you're going to have two answers. You could get x is 3 or x is -5. Both of those work. So when you have an equation, you can get multiple answers. With an expression, you can't. So now let's take that over to look at trig. If we have these two, the inverse sine of 1/2 and sine of theta is 1/2. Now we saw both of these kind of the same way. Now if you did inverse sine, we've looked at that previously. You can do inverse sine of 1/2 and get an answer, 30 degrees. If you didn't remember that necessarily off the top of your head, you would also always be able to go to the unit circle and remember that the inverse sine means the sine of what angle is equal to 1/2, and we got 30 degrees. Now, if you remember that, we'd say, well, there are other angles that have the sine of 1/2. I mean, if we go on the calculator, yes, the sine of 30 is 1/2, but so is the sine of 150, so is the sine of 390, so is the sine of 750. So there's a lot of angles that have the sine of 1/2. But when we do the inverse sine, that is defined to mean one angle. It's an expression. There's no equal sign. Just like when we do the square root of 25, that's an expression. There's only one answer. Things change a little bit if we have the sine of theta is 1/2. Now, there are a whole bunch of answers that would solve that equation. And I just showed you a whole bunch of them on the calculator. 30, 150, 390, 750. There's a whole bunch of them that solve that equation. Now, you can think of that as if we look at the graph of sine. Here is the graph of sine. And if I want to know where sine is equal to 1/2, you can see there's a whole bunch of places where sine equals 1/2. Here, 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 here. We can keep going, and we know that this continues on and on and on to the right. And there's also answers back here to the left that go that way. So there's an infinite number of solutions. But what we want to look at today is, let's say we're only looking for one period. We're only going to look over 2 pi. So if you think about this graph, we are going to erase everything but one period. And now on that period, we want to find our solutions. And you can see we only have 2. Another way to think about this is we're going to look on the unit circle. And we're going to find what are the answers on the unit circle, whether we're in radians or degrees. So let's go back to sine is 1/2. And what this is going to mean is, if you think about, and I like to draw pictures, as you know. So if we think about our unit circle, sine is the y coordinate. And there are 2 places where sine is 1/2, 30 and 150. So we are only finding answers on the unit circle, 0 to 360. We're not finding all solutions. We're just on the unit circle. So another one, cosine of theta is square root of 3 over 2. And the same thing, cosine's the x coordinate. So I want to find where is cosine equal to square root of 3 over 2. 1 is right there. 1 is right there. So those are our 2 answers, 30 and 330. So we're just pulling those numbers right off of the unit circle. Now, it could be a little harder if we have tangent. Because if you remember, tangent is equal to sine over cosine or y over x, however you want to think of writing it. Since we're on the unit circle, we could say the y over x. So if you think about all of our values on our unit circle, there's really only a couple things that can happen. We could end up with a square root of 3 over 2 over 1/2, and that cancels the square root of 3. Now, you could get plus or minus depending on what quadrant you're in. You could get 1/2 over square root of 3 over 2. That is going to cancel and give us 1 over the square root of 3. And the other thing you can get is, if you're at the square root of 2 over 2 points, square root of 2 over 2, square root of 2 over 2, you could get 1. And I guess the other thing you could get is you could get a point like 0 over 1, which is 0, and then 1 over 0, which is undefined, it doesn't exist. But the main ones we're going to look at are these 3 over here with square root of 3, 1 over square root of 3, and 1. So if our answer here is 1 over the square root of 3, as we think about this, we need a y coordinate of 1/2 and an x coordinate as the square root of 3 over 2. Wrong way. So to do this, we want to think about, okay, our y coordinate is 1/2, our x coordinate is square root of 3 over 2. And because it's positive, they either both have to be positive or both have to be negative. So if we look at our unit circle here, where is the y, 1/2, and the x, square root of 3 over 2? And they either have to be both positive or both negative to get our answers. So our answers are 30 and 210. So tangent's the one that gets a little tricky. If you just kind of think of this kind of chart here of all these possibilities, it helps you think about where they're at. Now, that's if we're in degrees. Does it change much if we switch to radians? If we say sine of x is 1/2, it's still the same two places on our unit circle. It just changes our answers to pi over 6 and 5 pi over 6. So as you look at the homework, sometimes it will say solve on 0 to 2 pi. Sometimes it will say solve on 0 to 360. And I should mention that this is a parenthesis over here, not a bracket, because 0 and 2 pi or 0 and 360 are the exact same place. So if it's there, we go with 0, not the 2 pi. Try another one. Cosine is negative square root of 2 over 2. That is the x coordinate is negative square root of 2 over 2, which is here and there. And if we are in radians again, that's 3 pi over 4 and 5 pi over 4. Not much difference if you are in radians or degrees. It's just a matter of looking which one you write down. If we have tangent is negative 1, that tells us it has to be the 45, 135, 225, 315, where the x and y are the same. If it's negative 1, that tells me my square root of 2 over 2, square root of 2 over 2, and one of these is positive and one's negative, which tells me I'm either in the second quadrant or the fourth quadrant. So that is 3 pi over 4 and 7 pi over 4. The last thing we want to look at here is not just a straight tangent, cosine, or sine, but we're going to have to do a little bit of work to get it there. So here's one where we have 2 cosine of theta minus 1. Now in all of these problems, what you want to end up with is cosine of theta equals some number. And for today, all of these numbers you're going to end up with are numbers on our unit circle. So you're not going to end up with cosine of theta equals 1/5 or something that's not on the unit circle. So what I need to do here is I need to add 1 to both sides. Then I need to divide by 2, and I get cosine is 1/2. Now, I'm back to 0 to 360. So 0 to 360, cosine is 1/2, is the x-coordinate, is here or here. So I have 60 and 300 are my answers. So we're just getting these right off of looking at our unit circle. Here's a little bit harder one. Cosine plus the square root of 2 equals negative cosine. So once again, I want to end up when I'm done with cosine. You'll notice sometimes I have x, sometimes I have theta. So I'm going to add the cosine to this side, which gives me 2 cosine of x. I'm going to subtract the square root of 2, which gives me minus the square root of 2. And then once I divide, I get square root of 2 over square root of 2, which if we think about our unit circle, that's here and here. So my x's are 3 pi over 4 and 5 pi over 4. The last thing we want to look at is if you end up with something like secant or cosecant or cotangent. What you want to do is think about that this secant is equal to 1 over cosine. So you want to convert this back to cosine. And so if you flip 1 over cosine and you flip that over to just get cosine, you're going to take the other side and flip it over to get 1/2. And so now you end up with just cosine of 1/2, which would be 60 and 300. So when you do all of these problems, you're always going to end up with sine equals something, cosine equals something, tangent equals something. These are going to be a y-coordinate on the unit circle. This is going to be an x-coordinate on the unit circle. And this is going to be a y over x, like we've talked about. All right. You are now able to do the homework 6.1, Trig Equations 1.